The Bell telephone system brings you one of a series of programs on science to understand nature's laws.
Try that focus again, Jim.
Coming up.
Title's okay. Now let's test that first animation. Roll 2. Okay, hold it. Now sharpen the focus. Right. Hold roll 2.
Doctor, how was the sun born?
Don't know exactly.
You're a scientist and you don't know?
Could use my imagination, but you're the fiction writer.
Imagination? Well, we could ask Mr. Sun himself.
Yes, if we had a magic wand.
Sure, you've got it. Magic. Your science and my magic. We'll open up our story of our Mr. Sun with a little fantasy. You know, showmanship. Go back into time, show the birth of the sun out of time, stardust. Here, we'll turn back the clock.
Ooh, that'll only take you back 12 hours.
Oh, all right. We'll open up the curtain of our imagination. This'll be our magic screen. Yours will be just for facts. We'll pull back the curtains of our magic screen. We'll dream up a clock. There you are. A clock that's been ticking since time began. Our solar system, wound up by Father Time himself.
Do you see what I'm seeing?
Well, certainly. Maybe I could talk to him, huh? Hey, Father Time, how long has that sun clock been going?
A few billion years. Why?
Well, could you unwind it for us?
Unwind time? Man, are you crazy?
Well, I'm a fiction writer. We're auditioning a show about our Mr. Sun, and I thought that...
Show about me? Well, about time.
Look who's here. Hi. Yeah, we were wondering how it all happened at the beginning.
Nobody knows what happened at the beginning.
Oh, come on, Pop. Unwind us. They want to see how I was born.
You old hot gas bag, you keep still.
Now, don't flip your sickle, Pop. The man says it's just a show.
He's a romantic fool. If you want facts, ask your scientists.
Oh, we've got Dr. Research here for facts, but what I need right now is something to open this thing up with a bang. You know what I mean?
Certainly. My story should be colorful, romantic, not just facts. Here, I'll tell you how it should open.
Wait a minute, I'm telling this story. You're just imaginary.
Quiet! You want a show, don't you? Go on!
Yes, sir?
Set the stage for me.
Oh, yes, sir.
Getting the Academy Award ready.
Hey, he's taking over. How do you like that?
I like it. Let him go on.
Music. Lights. Color. Enter Mr. Sun from the east.
Good morning, Brother Earth. For the umpteenth billionth time, good morning. Good morning, Brother Bird, Brother Mountain, Brother Sea. Morning to you, Brother Gull, Brother Bee, Brother Fish. Good morning, all of you. Great day. Every day's a great day. You know me as the sun. Of course, what I really am is a star. An average, everyday type of star. Billions like me. I remember when primitive man first began to look up, to gaze in wonderment at the stars and planets sweeping across the face of the sky. That primitive curiosity was the beginning of all your science. Of course, they had some pretty odd notions about me. Some thought I was an enormous beetle trundling a fiery ball across the heavens. The ancient Eskimos thought I was a little man wearing thick furs to keep myself warm. But to most, I was a god. With fancy names and wardrobes. In Babylon, I was Shamash, and my sun temples were observatories. In Persia, I was Mithras. And to ancient Egypt, I was the great god Ra. Glory to the great sun god.
O thou perfect, thou eternal, thou only one.
Blame me for getting the swell head? But the name I liked best was Phoebus Apollo. The Greeks always did have a word for it. In my case, it was handsome. Apollo racing across the sky in his fiery chariot, making heavenly music on his golden ukulele. Oh, that was for me. I loved it. And then along came another Greek to spoil it all. A Greek who would rather think than worship sun gods. Anaxagoras was his name.
The sun is not a god or a person. It is a mass of red-hot stone, only 40 miles across and 4,000 miles away.
For blaspheming against the beautiful Apollo, Anaxagoras was banished from Athens. And I wasn't a bit sorry for him. But man had fallen for this new and fascinating mistress, his brain. Thinking began spreading like the measles. Everybody got the bug. The Greeks with their logic and philosophy. The Hindus with their algebra and your present number system. The Arabs with their early instruments like the astrolabe. And today, instead of temples, rituals, and hymns to the sun, it's domes, gadgets, charts, and numbers. I'm demoted to a specimen, a pile of facts and figures. A big blob of mass holding little blobs of mass together with gravity instead of with love. I think you're all through.
Who's all through?
Earthman, he's had it.
Why, you flaming idiot, they haven't even started yet.
In worshiping me, ancient man was reaching for the great light beyond. But modern man, he's got all the answers.
Mr. Sun, you mind if I butt in a moment?
Who are you?
Who, me? Oh, I'm the... Never mind. Thank you very much. Goodbye.
Would you mind if we listen in?
See here, you're not even real. I just made you up. You go wind your clock.
No, let them stay. I like your magic. Father Time, my name's Research.
Who?
A scientist. Howdy, Dr. Research. I'd like to hear what you have to say about Golden Boy here.
Well, it's a delightful experience talking directly to you and to Mr. Sun, especially for a scientist. I was just going to relate a few facts about Mr. Sun.
Facts? If you're going to tell my story, don't give the people equations and figures. Give them the real lowdown. Tell them what I mean to them. They've forgotten that. When they eat corn or bread or grapes or meat, they're eating sunlight. Their houses, furniture, cars, their nylons. Yes, even their moonshine is sunshine. Tell them if it wasn't for me, they'd have no eyes, because there'd be nothing to see.
That's enough. You're getting purple.
Why, if I put my light out, every living thing on Earth would be frozen stiff. And you scientists who know would be just as cold and stiff as the people that don't know.
Through blowing sunspots?
Yes.
Then apologize to Dr. Research.
Oh. Well, I'm sorry, Brother Research.
No apology necessary. Mr. Sun is almost right.
Almost?
Yes, Mr. Sun, your logic is a little on the romantic side, too. You say that you don't like facts, and yet you've just given us quite a list of them.
Oh, this may turn out to be fun.
No, Mr. Sun, we haven't got all the answers. Science has just opened the book. Yet in seeking for more knowledge, we too, in a way, are reaching for the great light beyond.
Doctor, that's it. That's it.
What's it?
The gimmick. Come into my office here. We put the show on for him.
For the sun?
Sure, it's a tough audience. Science shows, son, we're not all through. You get it?
Could be boring to him.
Could be.
You keep your corona on. What science has found out about you is more exciting than any fiction. You stick around, you'll see.
But we really don't know very much about him.
Oh, we know plenty about him.
What about the television people?
Never mind them. If this thing goes, we got a real show here.
Well, you remember where you come in.
I remember the weather, the fuel,
And you
the energy.
cut in on me if I get
I'll
stuffy.
cut in on you. But come on, roll 'em.
Roll 2. Here we go. Although Mr. Sun is 93 million miles away, and it takes his light 8 minutes to reach us, he's really quite close. The light from the next nearest star, traveling at 186,000 miles per second, takes over 4 years to get to us. We know Mr. Sun is so large, our Earth is barely visible alongside him. It would take some 340 worlds like beads on a string to make a necklace around his shining sphere. How much does Mr. Sun weigh? 1,000 worlds? 100,000? No, sir. He weighs as much as 330,000 Mother Earths. We also know that Mr. Sun is not solid or liquid, but a fiery ball of hot, glowing gases, consisting of some 95% hydrogen and helium, and a few percent all other elements. We know that this huge cloud of hot gases would expand, float away, dissipate into space, unless gravity squeezed it together into a tight sphere. The gases at the center of the sun are so densely packed by gravity that they're about 100 times heavier than water. And the pressure is around 1 billion tons to the square inch. While at the surface, the gases are so thin, the pressure is only about 1 pound to the square inch. We know, too, that the temperature at the core of the sun is incredibly hot, around 30 million degrees Fahrenheit, while at the surface, it drops down to just about 10,000 degrees. But here's a strange thing. As we go out from the sun into the corona, the temperature goes up again to over 1 million degrees at the outer edges.
Tell them why, Dr. Research.
We don't know why.
You don't? Well, what is the corona, anyway?
We don't actually know that yet.
Oh?
But we do know there's more to Mr. Sun than the shining surface we normally see, which we call the photosphere or sphere of light. Only when the moon moves between us and the sun and covers the photosphere completely in a total eclipse can we see the rest of Mr. Sun's thin atmosphere, the beautiful and mysterious corona. For many, many years, scientists have lugged their instruments to all parts of the globe, chasing eclipses. Expeditions spending months just for a 2 or 3 minute opportunity to see, measure, and photograph the eclipsed sun. Sometimes heavy clouds, failure, complete washout. Sometimes light clouds, measurements uncertain. But on happy occasions, perfect conditions. The corona is studied and photographed in the fullness of its glory. Your corona is most puzzling to us, Mr. Sun. We know that it rotates with you, but at no 2 eclipses does it look just the same. It pulsates, changes shape, and at times extends out millions of miles.
Why is that?
Just one of the many things we still don't know about the sun.
Look, hadn't we better tell them something we do know?
Want to hear any more, Mr. Sun?
I like your pictures of me. Got any more?
Oh, yes, lots. Roll 6. The camera's one of our main tools. Now, here's a normal picture of you taken by direct sunlight. It's rather flat. Your face has little expression. But about 60 years ago, Dr. George Ellery Hale of America and Dr. Henri Delant of France conceived this ingenious instrument called the spectroheliograph. It filters out all the light waves except the light from some particular glowing atom, as for instance, hydrogen. Let's look at a normal white light picture of the sun again. Now here, taken at the same time, is a spectroheliogram that photographed only the red light from glowing hydrogen atoms. Now your face is interesting, reveals character. Here's another spectroheliogram taken at the same time that photographed only the violet light from incandescent calcium atoms, which tells us even more about you. With the spectroheliograph, Dr. Robert R. McMath of the McMath-Hulbert Observatory near Pontiac, Michigan, made the first time-lapse motion pictures of the prominences and wrinkles on the face of the sun. From his pictures and from the many thousands of photographs taken at observatories all over the world, particularly at the Mount Wilson Observatory, we've learned a great deal about Mr. Sun, especially about those much talked of sunspots that mystified Galileo.
Ah, sunspots. There are such things, of course.
Oh, yes.
They're not just something that scientists see when they're tired.
Oh, they're very real, but very mysterious. They mystified Galileo when, through his original telescope, he first saw them moving daily across the face of the sun. And they've been mystifying us ever since. Spots can appear singly, like this one, or in groups like these, and quite often in distinct pairs. When photographed by red hydrogen light, they look something like giant, violent tornadoes seen from above. Spots range in size from mere pinpoints just a few hundred miles across, into which you could drop the British Isles, to huge ones, into which you could drop 100 planets as big as the Earth. Spots look dark, although they really aren't, because they're cooler than the rest of the surface. 7,000 degrees as against 10,000 degrees of the surface. Also, over the years, we notice a strange fluctuation in the number of spots, increasing to a maximum, decreasing to a minimum, in more or less regular 11-year cycles, which many of us believe affect our weather, our crops, and the growth of our trees. One of the most astonishing mysteries revealed by study of spots, Mr. Sun, is that your equator, or the middle of you, rotates faster than the rest of you.
The middle rotates faster?
Yes. For instance, if a line of spots were placed like runners at a starting line, from the sun's north to the south pole, and at a signal raced around the sun, they would end up like this. Equator winds in 25 1/3 days. Half north and half south tie for second. Time, 27.5 days.
Why is that? You don't know why. Okay.
Have you got any more pictures of me?
Hey, would it please you to know, Mr. Glory Puss, that you've been photographed more than all the Hollywood stars put together?
The most dramatic pictures, roll 7, the most dramatic pictures are taken with a coronagraph, which creates automatic total eclipses whenever the sun is shining. This very remarkable instrument was first constructed by Dr. Bernard Leo of France in 1930. Today, there are improved coronagraphs at the High Altitude Observatory at Climax, Colorado, under the direction of Dr. Walter Roberts, and at the Air Force installation at Sacramento Peak, New Mexico, presided over by Dr. J.W. Evans. The first user of the coronagraph in America was Dr. Donald H. Menzel of Harvard University. What happens in these red hydrogen coronagraph motion pictures in 1 second actually took place in about 5 minutes on the sun. The small sphere you see here represents the size of the Earth in comparison with the sun. Your surface, Mr. Sun, is a stormy sea of violent motion. Small spicules or geysers like these continually burst from blisters on the surface and jet up like little fountains, if you can call 5,000 or 10,000 miles up little. Compare them with the size of the Earth. Big flame-like eruptions like these are called prominences. They're vast clouds of gas that sometimes float idly, at other times shoot out at thousands of miles per minute, as if they never heard of gravity. Sometimes they rise in graceful ribbons or tangled streamers.
Beautiful, beautiful.
Some surge up like gigantic geysers. Others flow sidewise and downward, at times forming natural bridges. Portions of the prominences may even break off and go floating away, as in this picture. But the baffling part is that most prominences flow downward, gases materializing from seemingly nowhere and flowing down into sunspot areas for days at a time. Coronal rain, it's sometimes called.
Where does it come from?
Oh, of course, when it rains on Earth, we don't actually see the rain go up either. We only see it come down, although we know it evaporates up from the 7 seas. But where coronal rain comes from, we can only guess as yet.
Give him the whopper, Doc. Biggest solar explosion ever recorded. Greatest photographic shot in history.
On June 4th, 1946, a great arch of gas, hundreds of times as big as the Earth, rose up at a speed of 400,000 miles per hour. The arch expanded clear out of range of the instruments at climax in less than an hour and a half.
I remember that one. Sure blew my top that day.
Yes, we heard you. Roll 15.
You heard me.
Oh, yes, we hear you every day. You not only send us light waves, but you broadcast radio waves, which we are able to pick up quite clearly at special radio astronomy stations, which receive radio signals from outer space. Here's a sample of the radio message you send us on one of your noisier days. In Australia, they've recently done some brilliant work with radio astronomy. Dr. E.G. Bowen heads the group of radio astronomers. It's only in the past few years that we have discovered some strange things in the sky. Radio waves coming to us from many places in outer space. Radio astronomy is a brand new exciting tool for scientists, and with it we found out quite a bit about you, Mr. Sun, through the noises you make.
I'm beginning to feel like a goldfish.
You got him going, Doctor.
Well, doesn't all this spouting and erupting have some effect on the Earth?
Oh, yes, tremendous effect.
Doctor.
Roll 8. Well, for instance, when a large flare flashes up around a sunspot area, it immediately sends out a burst of powerful ultraviolet rays that hit the Earth in 8 minutes. But it also sprays streams of slower electrified fragments of atoms out into space as if from a hose. This solar spray of fine particles usually misses the Earth, but at times the Earth is in its path. Now, the Earth is a magnet with north and south magnetic poles and a magnetic field around it. The spray of minute particles shot from the sun, which takes some 30 hours to reach the Earth, is deflected toward the poles by the Earth's magnetic field. As this solar dust, stardust you might call it, comes down into our atmosphere near the poles and collides with air molecules, it creates the most beautiful spectacle of the aurora, also called the northern and southern lights. Dr. C.W. Gartline of Cornell University took this unique time-lapse motion picture of the actual aurora borealis. The Earth's rotation produces the apparent motion of the stars in the background.
But the effects of these ultraviolet bursts from the sun are not so beautiful. Voltage fluctuates, radio communications are disturbed, and although our radio engineers have performed near miracles in protecting our radio waves from this solar sniping, Doctor.
Roll 7C.
Sometimes this happens.
We take you now to London for a direct report from Sam Johnson. Come in, London.
This is Sam Johnson. There's an air of tense expectancy here in London. This morning, the Prime Minister...
Will you stop playing with that radio?
I ain't even touched it.
Well, then do something.
That was the momentous statement the Prime Minister read to us this morning. And now, back to New York.
What an engineer.
Wasn't the shoe.
No, it wasn't the shoe. Let's recreate what actually happened in terms of atmosphere and radio waves. Radio waves normally move in a straight line, but about 50 miles high in our atmosphere, there's an electrified layer called the ionosphere that reflects radio waves, making it possible to bounce them around the Earth. Now let's listen to Sam Johnson again.
This is Sam Johnson. There's an air of tense expectancy here in London.
Suddenly a bright flare occurs on the sun. A burst of ultraviolet rays disrupts the ionosphere.
This morning, the Prime Minister announced...
But radio engineers are right on the ball.
Bill, London's folding. Another SID, huh?
Yep. I've got another frequency ready for you.
Not yet. Wait it out a minute.
An SID means a sudden ionospheric disturbance, which is unpredictable. But usually in a matter of minutes, the ionospheric layer reforms again.
And that was the momentous statement the Prime Minister read to us this morning. And now back to New York.
But when big regions of the sun are intensely active, the spray of solar particles that causes the aurora can disturb communications for hours, even days.
But this type is predictable.
Oh, yes. Fortunately, it usually is. And since radio communication is so vital to the services, airlines, radio stations, telephone companies, ships at sea, recently observatories all over the world have begun to keep watch on the sun and make up a worldwide radio warning service. At the High Altitude Observatory at Climax, Colorado, at the Air Force Observatory at Sacramento Peak, at Kodaikanal, India, in Japan, in stations all over the globe, observers keep tabs on you, Mr. Sun, and send in information to the central collecting agencies, such as
The Radio Storm Warning Service of the National Bureau of Standards, where men under Alan Shapley analyze the data and try to predict when the solar storm will strike the Earth, especially the vital North Atlantic communication lines. Then, by radio, by teletype, by phone, the warning goes out. Severe magnetic storm will affect North Atlantic circuits. Lower frequencies or use southern routes.
That's fine. But, Dr. Research, what has puzzled you scientists most about the sun?
Roll 9.
Oh, yeah. Even I can give you that in one word. Energy. This lady's parasol has 1 1/2 horsepower of sunshine continually poured on it. Enough to run her washing machine, sewing machine, refrigerator, and vacuum cleaner. In full sunlight, our family car receives almost enough sun power to run it, if we only knew how to use solar energy directly. At the common rate of 2 cents per kilowatt hour, the sun sends the Earth $1 billion worth of energy every second, and it's coming to us free. 5 minutes worth would pay our national debt. 1 minute's worth of the energy that hits the Earth would pay the total annual income tax of all United States citizens. Oh, a happy day.
And yet what the Earth receives is only a minute fraction of the whole. Only 1 part in 2 billion of the total solar energy. The rest of the 500,000 billion horsepower goes out into space.
How does the sun generate this enormous amount of power, Dr. Research?
Yes, I don't eat, drink, or take vitamins. I never sleep or rest. Then how do I do it, brother scientist?
Well, we know at least part of your secret now. We know the answer not only to your energy, but to what makes other stars in the universe shine. Thermonuclear reaction. It's the key word that wound up the universe. Thermonuclear.
8 to 5, they've made a hydrogen bomb.
We certainly have, Mr. Sun.
And the news rocked the world.
But with you, it's old stuff. The equivalent of 4 billion hydrogen bombs have been going off inside you every second for some 4 billion years.
Give or take a billion.
What smart guy figured that out?
Dr. Hans Bethe of Cornell is the gentleman. In 1938, he announced that the source of the sun's energy is the fusion of 564 million tons of hydrogen into 560 million tons of helium each second.
564 to 560, where did the missing 4 million tons go? Just disappear?
Disappears as mass, as matter, but reappears as light, heat, and all sorts of radiation.
Quite a trickster, old Saul, making 4 million tons disappear. 4 million tons?
That he is. Roll 12. I brought along a trickster friend of mine, Thermo the Magician, who has an act which he claims explains the sun's magic.
I am Thermo.
I will do for you such a trick only me and the stars can do. Pay attention. This is one way to make a hydrogen bomb. Nature's way. So, hydrogen. 1, 2, 3, 4. What is hydrogen? The smallest atom from which you build all the other atoms. So, we will weigh the hydrogen. Scale. Each bottle weighs exactly 100 ounces. 4 bottles, 400 ounces. Remember that, 400 ounces. So, now, carbon. This is carbon. A piece of coal to you. That is what I start with. Hydrogen and carbon. So, now I will heat them. 30 million degrees I will heat them. How? In a hydrogen bomb, it is done by exploding an ordinary atom bomb to ignite the hydrogen bomb. For the stars, they do it by pressure, gravity, like our Mr. Sun. So, now I play Mr. Sun and heat the hydrogen and the carbon to 30 million degrees. Fire, 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 fire! Now I am ready. Number 1, hydrogen, come. I, Thermo, now give the command. Fusion. So, what have we here? Nitrogen, the gas what makes 4/5 of the air you breathe. Air. Now number 2 and number 3 hydrogen, come. Fusion. Now we have oxygen, the other 1/5 of the air you breathe. Number 4, fusion. Huh? Now we have coal again, same piece. And we have helium, what you fill balloons with. 4 hydrogens, if they are 30 million degrees hot, 30 million degrees. It is not children playing with matches. The 4 hydrogens come out 1 helium. The carbon comes back the same, you see? Same weight, no change. That's why we call this the carbon cycle. Now we weigh the helium. Should weigh 400 ounces like the hydrogen. Oh, yes, naturally. But it can be. The helium weighs 3 ounces less than the hydrogen. Where did the 3 ounces go? That is the magic of the stars. That is the secret of the hydrogen bomb. I show you. Come back, 3 ounces. Here is where they went. They changed into...
Now, the energy in those 3 little ounces that completely disappeared as matter, that energy is enough to raise the Empire State Building 2,500 miles high. Now, the carbon cycle, which is what Thermo just explained to us, is not the only way in which you can change hydrogen into helium plus energy. You may also use a very special and rare process in which you put 2 hydrogen atoms together directly.
Is that the famous proton-proton process?
Say, you've been reading. Mr. Sun, you do not annihilate or destroy just 2 or 3 ounces, but 4 million tons of hydrogen matter each second. That gives you your unbelievable energy, which you radiate out into space. We think that originally you were a great loose cloud of gas, mostly hydrogen, being contracted by gravity. As you were compressed, the temperature went up, just as the air in a bicycle tire gets hotter and hotter as you pump it. Finally, the temperature in your core reached the necessary 30 million degrees needed to trigger the thermonuclear reaction. Presto, the furnace was lit, never to go out again as long as you live, Mr. Sun. The hydrogen began burning into helium and energy. Gravity tries to compress you, burning hydrogen tries to expand you. The 2 forces just balance each other. Oh, it's perfection itself, a furnace made of its own fuel, an immense continuous hydrogen bomb operating at an even heat for billions of years. What a wonderful invention you are, Mr. Sun.
Which brings up a point. How long before he runs out of this here now hydrogen fuel?
Oh, he still has about 98% of his fuel left. But 50, 100 billion years from now, Mr. Sun, you'll perhaps run out of fuel. You'll expire, go wherever good stars go. We'll go with you because as you go, we go.
You see, you're not just a big blob of hot mass to us. You're the head of our family. We want to know more about you. We depend on you for our very existence.
Yes, in fact, we're depending on you heavily for the solution of two of man's biggest problems.
Well, at last I'm being appreciated. What did you say your name was?
Dr. Research, you big... What are those two big problems you spoke of, Dr. Research?
The first is the age-old problem of food. Roll 5.
And boy, the number of mouths that need food keeps increasing.
In 1650, after 25,000 years of man, our population had reached 500 million. By 1950, only 300 years later, the population climbed to 2.5 billion, 5 times as many. Out of all the human beings who ever lived, 1 out of 20 is alive today.
1 out of 20 alive today?
Isn't that amazing? We never had food enough for all in the past. We don't have enough for all today. 2 out of every 3 persons on Earth actually eat below the minimum necessary for health. Yet 100 million new babies are born every year. A yearly baby crop nearly equal to the population of all of South America.
And all born hungry.
Yes, our population's practically exploding.
I'll bet he doesn't know who grows his food for him.
Oh, yeah, we know quite a bit about that. That is, he does.
Roll 4. Our food is grown by a natural process called photosynthesis, which means putting together with light. Your light, the oldest, biggest, and most important manufacturing operation in the world. 99% of all our food and fuel is created by photosynthesis, a process that goes on only in plants, never in animals. On every green leaf, there are millions of submicroscopic little one-man factories, turning out more sugar than all the ships and railroads in the world could carry. And the head man of each factory is a little green molecule called chlorophyll, the only engineer with the know-how about this still secret life process. Chlorophyll is so small and so secretive that not even the most powerful microscopes can spy on him. Here's the way we think he works. The veins of the leaf bring him water from the roots. From the air, he grabs a molecule of carbon dioxide, CO2. He puts a water molecule and a carbon dioxide molecule together. And then he reaches for a piece of sunlight, and this is what we don't quite know, how he adds this sunlight.
And I'm not going to tell you either. You can darn well find out for yourself.
Quiet. Piece by piece, he adds more sunlight to his sugar cake. And then he pulls out an oxygen atom from the mixture and releases it into the air.
And the Russians didn't invent me either. I invented myself.
And then he takes some salts that come up in the veins, sprinkles them over the mixture for icing, and puts the completed sugar cake into a waiting artery. Out of this sugar or sunshine cake, the tree makes leaves, trunk, roots, and fruit. In the sea, chlorophyll produces even more food than he does on land. The whole surface of the seas is teeming with billions of tons of a minute single-cell vegetable called phytoplankton. These, in turn, are eaten by countless, almost invisible little animals called zooplankton, which are eaten by little fish, which are eaten by bigger fish, which are eaten by still bigger fish. Yes, all fish are ultimately made of chlorophyll sunshine cake. And when we catch them and can them, we're catching and canning sunlight. In fact, all animals feed on sunshine cake in one form or another. The energy the Junior gets from milk was in a contented cow 24 hours ago. And 24 hours before that, the same energy was in clover, which had absorbed it from sunlight that had come 93 million miles in 8 minutes from the surface of the sun, but had taken 20 million years to find its way to the surface from the sun's central furnace. So you see the energy that makes Junior run, that makes a porpoise leap, and makes me talk so much, That energy is hydrogen that burned in your central furnace long, long before man walked the earth.
You know, Brother Research, I'm beginning to like you. Do all the people know these things about me?
No, that's why this program.
What's the big hitch in the food problem?
For one thing, chlorophyll is too slow. Take any acre of forest or vegetables. The amount of sunshine converted to plant food averages only 2 tons of vegetable matter per year. But if all the light you send us could be used by chlorophyll, we could raise 2,000 tons of food per acre per year.
A little chlorophyll may know the big secret, but he's awfully inefficient.
Who's inefficient? I just make sugar. Can I help it if those silly trees build trunks and branches and roots out of it that you can't eat? What you're looking for is a plant that's all fruit. Oh, there is such a plant. All edible, too. And it multiplies faster than rabbits. But you scientists are too dumb to find it.
There you are, Mr. Man. Find the plant.
Oh, we found it already, Mr. Sun.
Roll 10.
Found it in freshwater lakes. A kind of green algae called chlorella. A tiny one-celled plant that has learned the mathematical trick of multiplying by dividing.
Each cell gives birth to from 4 to 16 daughter cells, which all grow up and repeat the process. Chlorella contains fats, carbohydrates, and up to 50% proteins, and is all edible. All fruit, as Mr. Chlorophyll would say.
All over the world, scientists are doing research on chlorella. In Japan, Dr. Hiroshi Tamiya of the Tokugawa Institute has done some of the most interesting and practical work. For there, food is definitely a problem. Into these troughs, water containing chlorella cultures is pumped. Nutrient salts are added. The troughs are covered with plastic sheeting to let in sunlight, while extra carbon dioxide is bubbled into the solution. When the culture becomes intensely green, the chlorella crop is harvested. After washing and drying, the fine powder looks like green flour. Mrs. Tamiya, wife of the director, has added this to regular flour and made excellent biscuits and cakes out of it. If these processes ever become practical, underfed populations may have a new, rich source of food.
Yes, indeed. An acre of chlorella can convert sunlight into some 20 tons of plant matter against 1 or 2 tons of an ordinary crop. But there's a second great problem facing us eventually.
For thousands of years, we got our fuel from burning wood. Sun power, Mr. Sun stored up in trees. Next, we put animals to work. Sun power from grass. Then came educated power to do work animals couldn't be taught to do. Human slave power to build roads, pyramids, and row ships. Sun power with brains. But slaves had to be fed. So we discovered power that didn't eat, like windmills and water wheels. The machine age was born. But modern machines need to be fed too, fed with fuels. Where do we get the fuels?
From the big fuel man himself. Over the ages, Mr. Sun was kind enough to store them up for him.
Chop for living sunshine. Dig for fossil sunshine. Drill for liquid sunshine. Dams for silent sunshine. Fuel. Fuel. More fuel.
Well, how much fuel's in the bank? How big is the trust fund the old boy left us? Roll 13. Well, suppose all our energy had been deposited in the Sun Power Bank Incorporated, founded millions of years ago, with assets unlimited. In 1850, each American, for instance, withdrew enough fuel from the fuel bank to generate 400 horsepower hours for himself. But nobody worried too much about it. Our assets still appeared unlimited. In 1950, each American withdrew 10,000 horsepower hours from Sun Power Incorporated, while atomic scientists were making some minor deposits. This began to worry us. Our assets were becoming definitely limited. By 1975, we'll probably withdraw 20,000 horsepower hours each. atomic energy fuel deposits will stave off the run for some time, but there's only so much uranium and thorium in the world, and that will go too.
When the principal's gone, you're going to have to live on your income, huh?
But our income is only about 10% of our power spending. Going to need help.
Every day I send you 1,000 times more power than you use in a year. It's up to you, fellows.
Anybody working on getting power direct from old Blowhard here?
Oh, yes, but not nearly enough. Roll 6B. Some years ago, Dr. Charles Greeley Abbott, an enthusiastic pioneer in solar engines, designed this vacuum-jacketed boiler tube at the focus of a parabolic mirror, which will convert sunlight to engine power. Today, the French Laboratory of Solar Energy has an enormous solar furnace at Montlouis for metal research at high temperatures.
In India, Dr. S. Bhatnagar, the famous Indian scientist, experimented with solar cookers for home use. On one of these cookers, an Indian family can cook its noonday meal with no heat other than the sun's heat.
Some other ways depend on glass. Sunlight coming through a window heats up everything in the room, but heat radiated back from furniture and floor is long heat waves, which the window glass stops from going back out, thus trapping the sun's heat.
Is that why greenhouses covered with glass are warmer inside than the air outside?
Right. That's why your closed car gets so unbearably hot standing out in the sun. Dr. Maria Telkes has designed a model house in Massachusetts in which solar heat is ingeniously collected, stored, and distributed throughout the whole house. Now, these are more or less well-known mechanical ways of using sun power directly. There's exciting research going on with some brand new ways.
You think Mr. Chlorophyll was pretty smart with his tricky sunshine cake that makes food out of your sunlight? Well, the science boys have come up with a sunshine cake that makes electricity out of your sunlight.
Oh, yes. You mean the solar battery?
Yeah.
That's hardly even a cookie yet, let alone a cake.
Doc, that's big news.
Well, the solar battery. Now, held in the sun, this thin little cell, a sunshine wafer we might call it, produces a usable amount of electric current out of the sunlight that falls on it. It was cooked up out of basic research at the Bell Telephone Lab by 3 scientists, Darrell Chapin, Calvin Fuller, and Gerald Pearson.
You know, although this is quite expensive at the moment, the simplicity of this sunshine wafer is startling. I want to bake one for old Glory Puss, Doc.
I'd be delighted.
Well, get him. Old pastry cook research.
The recipe for this solar wafer sounds just like a vacation. Just sand and sunshine. Thank you, son. Plain old sand is composed of silicon and oxygen. Its Sunday go-to-meeting name is silicon dioxide. Separate out the oxygen and the bits of seaweed, bottle tops, and other odds and ends. And we have left a metal, silicon. But our silicon must be pure silicon. So we purify it and purify it until it's as pure as the driven snow. Now melt the silicon and add just a pinch of arsenic for flavor. Mix thoroughly and cool until it crystallizes. Then from the arsenic-flavored silicon roll, slice off a razor-thin wafer. Put the wafer into the oven. Fill oven with a boron gas and bake to white heat. And the boron cooks into the surface, forms an extremely thin icing over the wafer. Remove finished wafer. Connect one wire from electric motor to boron icing and the other wire to the wafer itself. Expose wafer to sunlight. Presto! The motor starts running with the efficiency of an automobile, and nothing is used up but the sunshine, which is free.
Ain't that something?
Well, I'll be darned.
So you see, in a solar battery, it's energy from the sun that moves the electricity, which in turn rotates motors. Or, as in this case, powers rural telephone lines by charging storage batteries. But the solar battery isn't all. there's other important research in changing sunlight into power. Dr. E.I. Rabinowitz has put together a chemical cell that'll change light waves into electric current. But storing sun power for night use is a big part of this energy from sun problem. Well, Dr. Lawrence J. Haidt of MIT is experimenting with a process in which sunlight decomposes water back into oxygen and hydrogen, the hydrogen being a storable fuel. Another possibility, phosphors are chemical powders that absorb sunlight and can give it back slowly in the dark.
I read where Westinghouse engineers predict a wallpaper containing phosphors which will absorb daylight during the day, then glow for hours after dark. A city painted with phosphor paint of the future might glow all night.
These are some of the processes that are being researched on a small scale today, Mr. Sun. But our engineers can't turn the wheels of industry on little wafers. They'll have to build efficient generators that spread out over acres, even square miles, to compete with the cheap coal and oil still available to us.
But, Doctor, what about atomic power?
Oh, great hopes for it, of course. Especially now since atomic plants can make their own fuel with so-called breeder reactors. Some even dream of imitating the stars, getting power from hydrogen fusion. But if dreams fail, the answer must be sun power from our Mr. Sun.
What if you don't find ways to use my free sunshine for fuel?
Then the machine age is over. We'll have to go back to muscle power and the 500 million population that muscle power alone can support.
But that will never happen.
Oh, no? Why not?
Because man's greatest power source is his mind. God gave him that, not you. Without taking a step, he can travel faster and farther than any animal. Without even getting wet, he can outswim any fish. Without a feather on him, he can fly faster, higher, and farther than any eagle. He can send his eyes and ears hundreds of miles into space where he's never even been. And he's pried open the secret of the atom that he's never even seen. When his fuels run low, man's mind and imagination will meet the challenge and invent undreamed of ways to use the free sunlight God showers down upon him. Just remember, somebody must love you very much. That planet that you live on is not like all the rest. You're blessed with just the right size, the right temperature, the right atmosphere, the right composition. Everything just right to produce the biggest miracle of all. Life. So go ahead. Ask, inquire, seek the truth. It's right that you should know, or the good Lord wouldn't have given you that driving curiosity. Measure the outside with mathematics, but measure the inside with prayer. Prayer is research too. Study man as well as the world. So keep on pitching. The best is yet to come for you. I predict man's next great adventure will be the Sun Age. When that happens, you will be rich beyond all dreams. I predict great sun cities built on desert wastelands where everything is run by sunlight. I predict...
Oh, sure, that's fine. But suppose I begin cutting up, then what?
You won't. But if you did, man has migrated many times before, and he'll do it again if he has to. Hey, if you make it too hot for him on Earth, man is capable of conceiving a way to move the whole kit and caboodle to greener pastures on some other planet.
Oh, no, we like it here. Don't change on us, Mr. Sun. We used to worship you as an unknown god. But now that we know you better, we love you as our great and good friend. So keep on shining, Mr. Sun. Praised, my Lord, in what you have created. Above all else, be praised in our brother, Master Sun.
Good night, Brother Earth. Now you're cooking with sunshine.
The Bell Telephone System takes pride in bringing you this program in its series of shows on science. We wish to express our gratitude to the distinguished Board of Advisors who guide the choice and treatment of scientific matter for the series. For the program you have just seen, our thanks to the special advisors who have suggested and checked the scientific material. The Bell Telephone System is indebted to all these men and to many institutions for the generous support they have given this venture in public education through entertainment.